Bernoulli's equation under calculus. How to use Bernoulli's equation to solve first order linear non-homogeneous equation. Okay, Bernoulli's equation is of this form: dy over dx plus axy equal to bx y exponential n, where ax and bx are functions of the Bernoulli's equation, or they are also constants. So quickly we'll be running through a very good example of how to use Bernoulli's equation to solve first order linear non-homogeneous differential equation. Okay. First of all, write out the equation x squared y minus x raised to the power 3 dy over dx, which is equal to y raised to the power 4 plus x. Okay, from this equation, let's compare this equation to our standard equation, which is compare, let's say this is equation 1. Compare equation 1 to standard equation. The standard equation of Bernoulli's. So from Bernoulli's we have that dy over dx plus ax y is equal to bx y exponential n. We can see that from this equation, comparing it with the standard equation, they are not alike, because our dy over dx are on this way. So what we are going to do is to try to rearrange the equations so that it can look like this form. Okay, rearranging the equation. Rearranging the equation. Okay, let's see how we can make the equation look like the standard form. Let's move this x squared y. This becomes minus x raised to the power 3 dy over dx plus x squared y equals to y raised to the power 4 plus x. Okay, you can see it's looking like that form. You can also divide through by x raised to the power minus 3. So dividing through by minus x raised to the power 3, we'll be having minus x to the power 3 dy over dx divided by minus x raised to the power 3 plus x squared y all over x raised to the power 3, also y raised to the power 4 plus x divided by minus x raised to the power 3. You can see that this one is going to cancel out this. So we're having dy all over dx. Then this part, our x is going to cancel out this x. We'll be left with plus y all over x plus y all over x. Then for this part, our negative minus, our minus will come to the upper part, it become minus y raised to the power 4 plus x all over x raised to the power 3. We can see that this equation now is looking like our standard equation. You can see that this equation is looking like our standard equation. So we can call this equation equation 2. You can call this equation 2. Then let's see, how can we separate take y, but take y raised to the power 4 to this other part. Let's say we multiply both sides of the equation. Multiply both sides of the equation by 1 all over y raised to the power 4. So let's multiply 1 all over y raised to the power 4 throughout the equation. Then we'll be having 1 all over y raised to the power 4 multiply by our dy all over dx. Also plus y all over x multiplied by 1 over y raised to the power 4. Also, let's say this becomes minus cos x all over x raised to the power 3 times our y raised to the power 4. Then we are multiplying this part by 1 all over y raised to the power 4. So looking at this, we can see that our y raised to the power 4 will cancel out this part. Then we'll be having from here we'll be having, let's make our y raised to the power 4 fractional part. That is, moving the fraction from it becomes y raised to the power minus 4. Removing the fraction, it becomes y raised to the power minus 4 dy all over dx. Then for this part we can see that y can cancel out this y. Then this part will be left with y raised to the power 3. So here will become plus 1 all over x y raised to the power 3. Then also this part becomes minus cos x all over x raised to the power 3. This can also be written as y raised to the power minus 4 dy all over dx. Then plus, this can be written as 1 all over x. Then let us remove this fractional form. It can be written as y raised to the power minus 3 equal to minus cos x all over x raised to the power 3. Form, we can now say let w become y raised to the power minus 3. Let w become y raised to the power minus 3. We want to make this equation a linear form whereby we can be able to solve it easily. So let's say w is equal to y raised to the power minus 3. Then now, let's differentiate this w in terms of x. Differentiating this w in terms of x, let us use the chain rule. Using the chain rule, this becomes dw all over dx is equal to dw all over dy multiplied by dy all over dx. Okay, whereby this dy and dy can cancel out itself, you'll be left with dw all over dx, which is the same thing as dw all over dx. Okay, from this part, let us differentiate from here. dw all over dy, let's differentiate w in respect of y. We'll be having dw all over dx, differentiating y, dw in terms of y, we'll be getting minus 3 raised to the power minus 3 minus 1. Minus 3 minus 1, which will become minus 4. Which becomes minus 4. Then our dy all over dx, you can see that there is no x here. So our w does not have any term related to x. So this dw all over dx will remain dy all over dx. Okay. Then let's see that we are going to substitute this equation. We are going to substitute w and dw all over dx into this equation. Let's call this equation 3. We are going to substitute it into equation 3. But if you take a look, this dw all over dx, it almost looks like this one, but there is no minus 3 here. Our w can be written here. So let us multiply equation 3 by minus 3. Okay, what we are trying to do, we are trying to make this other part look like our minus 3 raised to our y minus 4. So multiply minus 3 to equation 3, you get minus 3 times y raised to power minus 4 dy all over dx plus 1 all over x y raised to power minus 3 multiplied by minus 3. Then this part we are getting minus cos x all over x raised to power 3 multiplied by minus 3. Okay, from this part, this one becomes minus 3y raised to power minus 4 dy all over dx. Then this part becomes, the negative part multiply our positive becomes minus 3 all over x y raised to power minus 3. Then this part, our negative cancel out negative, so here becomes 3 cos x all over x raised to power 3. Okay, let's call this equation 4. So now we can now substitute our w and the w all over dx into equation 4. Okay, substitute the value of w and dw all over dx into equation 4. Okay, from equation 4 we can see that our minus 3y raised to power minus 4 dy all over dx is equal to our dy, our dw all over dx. So in place of this fraction, we are going to replace it with dw all over dx. So this part becomes dw all over dx. Then this part becomes minus 3 all over x. Then we say that we are replacing our y raised to power minus 3. We are replacing our y raised to power minus 3 with w. So this place becomes w equal to our this 3 cos x all over x to the power 3 remains the same. Okay, from this part, we can now use our integrating factor to solve this. Now from integrating factor, using integrating factor, Using integrating factor, which is written as if cos of exponential partial a x x. Okay, this is our integrating factors formula. We can recall that our Bernoulli equation follows the form dy over dx, dy over dx plus ax y equal to b dx y exponential n. Okay, we can see that our ax from this equation, let's call this equation 5. Let's call this equation 5. From equation 5, you can see that our ax here is our 3 all over x. Then our w can represent our y. So therefore, our integrating factor become exponential integral. In place of our ax, we write 3. We are going to write 3 all over x. Then our dx. Okay. From this now, for us to integrate this becomes exponential. We move our constant 3 outside the integral form, becomes 3 integral 1 all over x dx. Okay, from integration, if we integrate 1 all over x, we'll be getting 3 ln x. We'll be getting 3 ln x. Then from our logarithm will, our 3 will go up to this x, becomes exponential ln x raised to power 3. Then exponential will cancel out ln. We'll be left with x raised to power 3. We'll be left with x raised to power 3. Therefore, our integrating factor is equal to x raised to power 3. So now, since we have gotten our integrating factor as x raised to power 3, we can now multiply our integrating factor to equation 5. Okay, let's multiply equation 5 by x raised to power 3. Multiply equation 5 by x raised to power 3. We'll be having okay. Multiply equation 5 by x raised to power minus 3. We'll be having x raised to power 3 dw all over dx minus 3 all over x multiplied by x raised to power 3. Then also 3 cos x all over x raised to power 3 multiplied by x raised to power 3, our integrating factor. Okay, so I can clean this part now. Okay, from this becomes x raised to power 3 dw all over dx. Then our x will cancel our x. Then this part will become x raised to power 2. Therefore, minus 3x raised to power 2, then w is equal to our x raised to power 3 will cancel out x raised to power 3. We'll be left with 3 cos x we're left with 3 cos x. Then from here now, we can see that there are similarity between our x raised to the power 3 w all over the x minus 3x squared w. There are similarities, and I will break it down. So from there, we will get, factorizing this, we'll be getting d all over the x bracket. We'll see that x raised to the power 3, then w is equal to 3 cos x. Okay, the question can be, how do we get this from this part? How do we get this? We can use product. If you use product rule, if you apply product rule to this form, you are going to get back this equation. Apply product rule, you are going to get back this equation. You apply product rule. Okay, let's try it for examples so that we can be clear. For example, from our product rule, we will say that let our x raised to the power 3 be u. So let's keep w constant and differentiate this one. If we differentiate this one, we'll be getting 2x raised to the power 2, then multiply by our w, then plus, we'll keep this one constant. We'll keep this one constant. We'll keep our 3x constant and differentiate our w. Then we'll be getting x raised to the power 3. Then if you are differentiating this one, since this does not have the term x, so it will become dw all over the x. Then rearranging it, it becomes x raised to the power 3 dw all over the x minus, okay, sorry, this part is supposed to be 3. Sorry, 3. Okay, minus 3x squared, then our w. You can see that from this part you can factorize it and get this form. So from this part now, you can now integrate both sides. Integrating both sides, that is integral d all over the x raised to the power 3 w, then integrating 3 cos x. Okay, integrating this, our integral form will cancel out this, will be left with x raised to the power 3 w. Then if you are integrating this one, our 3, that is the constant, will come outside, then we integrate cos x, then it becomes 3 sin x. Then let's make our w subject of formula, that is w is equal to, we divide both sides by x raised to the power 3, this becomes 3 sin x all over x raised to the power 3. Okay, but let's recall that our w, was written as y minus 3. Our w was written as y raised to the power minus 3. Then we cannot substitute our y raised to the power minus 3 to this part. Then it becomes, okay, sorry. It's still there. Okay. If we substitute our y raised to the power minus 3 to this, it becomes y raised to the power minus 3 equal to 3 sin x all over x raised to the power 3. All over x raised to the power 3. Okay. Then from this part now, we can now make our y the subject of formula. Therefore, this will become 1 all over y raised to the power 3 plus 3 sine x all over x raised to the power 3. I can please. Okay, from this part, we can multiply our y raised to the power 3 to this. It becomes y raised to the power 3 sine x. Okay, let's remember, since we have integrated this, we are going to add our integrating constants, which is c. So here is plus c also. Therefore, here plus c. So here becomes 3x plus c. Then 1 minus 1 times our x raised to the power 3 becomes x raised to the power 3. And now we can now make our y subject of formula. You have question? Okay, ask.
The question is that is of adding the integrating factor.
I've cleaned it.
Yeah, they have cleaned it. Maybe after now this.
Okay. Then from here now we can make y subject of formula, which is y raised to the power 3, then divide through by 3 sine x plus c. Okay, let us remove our power from, so it becomes y raised to the power the cube root of x raised to the power 3 all over 3 sine x plus c. Okay, this is how we can use. Okay, I have a question. Okay, this is how we can use Bernoulli's equation to solve our first order linear non-homogeneous differential equation. There will be more questions. There will be a quiz on this video, so you're going to try out the quiz and get back to me.